This is the continuation of creating a geological database in Surpac. In the previous lesson, we created the Microsoft Access database and the geological database file from raw drill hole data. And we realized that when we viewed the content of the Microsoft Access database and we opened the various tables, there were no data in them. So all that we were left with is to import the data from the CSV files into the Microsoft Access database. We also view the content of the geology database file. This is it. All the tables that we loaded, their character length and decimal places were also viewed. Okay, so this is the file that Surpac requires to connect to the database, and this is the Microsoft Access database that will contain our actual data. Before we do the import, we have to first get connected to the database. So we just click on it and drag it into graphics. So I have mine connected here. So we begin by doing a new import. Go to database and select import data. When we are doing this, then we want to tell Surpac that we want it to pick the arrangements that we have in the CSV file into the Microsoft Access database, so that as time goes on, when we are loading by a special load type from the CSV files, Surpac will pick the arrangement straightforward. Okay, so I'll just select the import data. Then here, the name that we gave to the database was new database. So we'd have to have the name of the format file as the same as the report file name. So I'll just copy this and paste it here. Okay, the difference between the format file name and the report file name is that the format file name is the name of the header in the text that will be contained in the node file, and the report file name is the header that, or the title bar of the report that will be produced, and the format is selected to be a Surpac node file. We can click the drop down to see the list of formats that we can choose: PDF, hypertext markup language, PostScript, and so on and so forth. We are going to use the Surpac node file. So I'll click apply to continue. And it says new database.dsc will be created. The .dsc is the file extension for a description file. So when you see .dsc, the dsc simply means description. A database description file is a text file used in the database build process to explicitly define how your database is built. So then new database.dsc will be created, and this will show how it will describe how the database was built. Okay, so I'll click apply to continue. And here we have various sections. It says select the tables to include in the format. We have table name, include, format, delimiter, spacefill, and text qualifier. I will explain each and every section here one after the other. The table name are the tables that we want to include in our database. We only have these 4 tables: color, survey, assay, and geology. Translation and stars are Surpac's default, so we wouldn't bother ourselves with that. Then the include section. Anytime you check a box for a particular table name, that's supposed to mean that you want to include the table into the database. For instance, if I uncheck the box for color, the color table will not be included into my database, but we want to include all the tables into our database. Then I go to the format section. We have 2 types of formats that we can import our data from. We have the free and the fixed format. The free format describes data in columns that are separated by a certain character, usually a comma. That's what we have here in our CSV files. When you are mentioning the headers here, we have whole ID, sample ID, meter from meter to average gold values, and sample type. Even though the commas are not seen here, the way you mention them indicate that there is a comma separated file. Okay, then we go to the fixed format. The fixed format describes data which exists between specific columns. If, for instance, for the color table, assay table, you want to import a particular field that you have fixed, then you choose the fixed format. But looking at our tables, they are all CSV files, so they are free format that describes data in columns that are separated by a certain character, usually a comma. So we will choose first. We will choose free for the format type. Then here you can go through the list of delimiters that we have. Because we are choosing the free format, that's a comma separated file, and the delimiter is a comma, we will select comma as our delimiter. Then I go to the space fill section. Anytime a space fill box is checked and a particular field for a table is not loaded, then that particular field will be reported as blank. The space fill column works as the null section in defining the fields for the various tables in the previous lesson. So the space fill works the same way as the null box. So these boxes means that anytime we decide not to load a particular field, then Surpac should report that field as blank. Then I go to the text qualifier. The text qualifier is usually associated with memo fields. That's a multiple line memo fields. You enter a particular text qualifier that you want Surpac to place around all text and memo fields. Okay, so here we are going to maintain it as it is and click apply. And the table appears for us to enter the column numbers for the various fields and tables. Here we are going to enter the column numbers. Looking at the color table, for instance, as we can see, the whole ID is column 1. These are the columns and these are our rows, so take note. So we are going to enter the column numbers within the CSV and put them onto the Surpac database. So here whole ID is 1, Y is 2, X is 3, Z is 4, and we are going to include them. Let's look at the CSV file to verify that. Whole ID 1, Y 2, S 3, elevation 4, maximum depth 5, whole type 6. You should conform to what you have in the CSV so that you wouldn't have problems importing the data. 1, 2, 3, 4, maximum depth is 5. Whole part is not in my color table. Whole part is not in my color table, it's rather whole type, and is the seed column. So I have to change it to suit what I have in the CSV file. I'll enter 6 and I'll enter 0 here because I don't have it and exclude it. Okay, then I will go to the survey table. I have whole ID. Let's look at the survey table. I have whole ID 1, depth 2, depth 3, azimuth 4. Simple table. Whole ID 1, depth 2, depth 3, azimuth 4. Perfect arrangement. Then I'll go to the assay. Let's look at the assay table. I have whole ID 1, sample ID 2, meters from 3 meters to 4. Okay, whole ID 1, sample ID 2, depth from 3, depth to 4, average gold value 5, sample type 6. Perfect arrangement. Then we go to the geology table. We have whole ID 1, meter from 2, meter to 3, radius 4, lithology 5. We have to whole ID 1, sample ID 2. We do not have a sample ID in the geology table, so we have to change it to suit what we have in the geology table. So here sample ID has no column, so I'll enter 0 and exclude it. Then the depth from is rather 2, so you have to change it to suit what you have in your CSV file. The depth 2 is 3. Then we have the radius to be 4 and lithology to be 5. Okay, the styles table will be arranged by Surpac, so we wouldn't worry ourselves with that. So we are through with defining the fields into the database. So I'll click apply to continue. Okay, so on this form I'm to select the type of tables that I want to load into my database. As you can see here, we have perform overlapping sample check. When this box is checked, any sample interval that seems to be overlapping will be produced as error in the database. And this is usually done on the assay and geology tables. For instance, if you have an interval such as 0 to 1, 1 to 2, 2 to 3. And you have a sample interval of 0.5 to 1.5. 0.5 is between 0 and 1. And 1.5 is between 1 and 2. So there will be a sample overlap. So we want Surpac to perform a sample overlap on the geology and geology and assay tables, which are interval tables. Then the maximum errors allowed during load has been preset by Surpac to be 50. That's supposed to mean that when errors more than 50 are encountered, then your data is seen to be incorrectly loaded. Okay, so I will go to the test file name section. Here we are supposed to provide the names of the files that we are going to load our database from, and these are the tables, that the test files, the CSV files, assay, color, geology, and survey. Okay, and the load type. The load type, there are 3 types of load types that one may choose. I'll click the drop down for us to look at it. We have the insert. When you select insert, only new records which don't exist in your database will be loaded. That's in the early stages when you are now creating a geological database. For instance, in ours like this, we do not have any data in there, so we can choose insert to insert new records into our database. When you select update, only records which already exist in the database will be updated. Thus, you already have a database created, so the CSV files have been edited and you are loading it. Or any record that already exists in the database and you have it edited in the CSV will be updated. The insert and update load type will also load records from the test files and update already existing ones. So for the insert and update, new records will be entered into the database and already existing ones will be updated. So let's say that our data, we already have some data in there, even though when we open the Microsoft Access database, the tables were filled with no data. We will choose the insert and update so that as time goes on, when the CSV file is edited, new records will be inserted and already existing ones will be updated. So we will use the insert and update option. So these are the table names that we are going to import. We do not have translation table and styles table. All that we have are the styles table. So I will select my styles, my color table from the color CSV file. Then I'll enter the survey from the survey CSV file. Then I'll choose the assay from the assay CSV file. Geology from geology CSV file. So I'm loading my tables from the CSV files that I have. Then the load type, I'll select insert and update. I've already explained them. Insert and update. Okay, so I'll click apply to continue. Any error that will be encountered in the database will be written to a different file and it will not go into our database. Notice the files that we have in the work directory, which is the database. We have these 4 tables: the assay, color, geology, and survey, and the description database file, the .dsc, the ddb, and the mdb. So these are the files that we have. So I'll click apply and the errors will be run through the database. Very good. So they've been produced here. Okay, beautiful. So this is the note file. As you can see, initially we were supposed to provide the format file name and the report file name. The report file name is the header of the file that will be produced, and the format file name is the name or the header of the text in the file that will be produced. Okay, let's look at the content. Here the report file name is shown as the new database. That is what we have. The new database, that is what we have created, and the date that it was created, the database name, and this is the format file name, new database.dsc. The dsc is the description, how the database was built. So as you can see here, the errors that were encountered in loading the database have been shown here. So loading table from color, these were the errors that were encountered. Value for field whole ID contains illegal lowercase characters. In defining the fields for the whole ID, Surpac only produced lowercase characters. There were none of the tables or fields that had a capital letter. When we were loading the fields, their character length and so on and so forth, Surpac only provided us with lowercase characters. That's why it is reporting our whole ID from the color table as illegal lowercase characters. Let's look at our color table. When you look at the whole ID, the text, we have capital letters for H and I and D. So it has reported that as error because it only brought us with lowercase characters whole ID, even though we do not have an option to select the header. Okay, so it says value for whole ID contains illegal lowercase characters. Y is not numeric, S is not numeric, Z is not numeric. Let's look at the CSV file, color table. Y is not numeric. Looking at this text, local north, this is a character field, but we only took into consideration this. We selected this as real, Y as real. In creating the geological database, we chose this as real. But Surpac did not provide us with a header option for us to choose what the headers are. So we selected this to be numeric, but the word local north is a character, so it has reported that as an error. It says Y is not numeric. That is why Y is in quotation marks. S is also in quotation marks and is reported as not numeric. Looking at the color table, S is also text, but we only chose the numbers as real, numeric values with decimal places. Surpac did not provide us with header for us to choose what the headers are. Okay, and the maximum depth is also not numeric, whole ID, this. So these are the fields or the headers from which Surpac has read the error. So as you can see, the same thing went for the survey. Depth is not numeric, depth is not numeric, azimuth is not numeric. So these are in quotation marks. The word depth is not numeric. We were not provided with a header option for us to select what field type is depth. Okay, that's why Surpac has read the errors from the header of our tables. So anytime you are loading a database, expect one error that will be read from the header record. Okay, so let's see. No overlapping sample checks were found. As initially discussed, I said the overlapping sample checks will be done on the assay table and the geology table. So no overlapping samples were found for the assay and the geology. So as you can see, only one record were encountered in loading the database, and they are as a result of the header record. So Surpac read the errors from the headers. Okay, so we are done. As you can see in our work directory, some files have been created in addition to the already files that we had in the database. We have access table.reg. reg is the file extension for a rejected file. So it has been created for the assay table, the color table, geology table, and the survey table. So all the errors that were encountered in loading the database have been placed in this rejected file, the .reg. Okay, we also have here .dsc. I've already talked about it. That's the description file for the database. These files, the rejected files and the description files, cannot be opened in the Surpac window. You require a particular application to open it. Okay, so we are done. Let's have a look at our Microsoft Access database if truly our data have been imported. Let's look at the assay table. Everything is here. So we have the geology, color, survey. So all that we have in the CSV files have been imported into the Microsoft Access database. The arrangement, how they have been arranged in our CSV files, have been brought into the Microsoft Access database. So anytime the CSV file is edited, all that we need to do is to import it with a particular load type. Okay, so these are some of the things that you will do after creating or importing your data into the database. You can go to edit, view table, then you select the type of table that you want to view. I say color geology style survey translation. Let's say I want to view the color table. I'll select it and click apply. If there are any constraints that you want to apply, you insert them here, but let's first view the table first. Okay, so these are the tables. Page 1 of 1 is just a single page. Okay, you can also go to edit, view table constraint. Let's say I want to view the color table. Apply. Then these are the rows that I can select from to use to constrain the table. Let's say I want to view tables that have maximum depth of 100 from my color table. I'll click apply. So there are 7 holes that have maximum depth of 100. Anytime you select a particular constraint, the number of constraints that you set must be met before they will be displayed for you. Okay, you can also go to edit table, and select the particular table that you want to edit. You see, when I click on the coordinates, they have been highlighted. That means you can enter any coordinate of your choice and click apply after editing. But when you select edit view table, you can't edit anything in the table unless you use the edit table menu to do whatever you want to do. So if, for instance, I want to change this decimal place to 5, I can enter it and click apply. Okay, I wouldn't edit my data. I'm okay with what I've done now. You can also go to edit and insert new records for a particular table. Let's say I want to insert a record for the assay. You just scroll to the bottom, click and choose add, and you add it to your record. Okay, you can also go to the same edit, delete records, and it will be deleted from your table. You can also rename a drill hole by providing the old drill hole ID and entering the new drill hole ID. You can also transform drill holes. If you have, maybe you want to transform it from mine grid coordinates to national grid coordinates, all that you have to do is to provide the coordinates here and you are done. Okay, you can also change the bearing of the drill holes. If due to magnetic declination you would want to adjust the bearing or correct the bearing, you would enter that magnetic declination here. Okay, so I'll connect to the database. Already connected. I'll just go here and display my drill holes, and everything is here. So these are the drill holes, very few drill holes. Okay, so as you can see, the holes are appearing green. So in our next lesson, we will set the styles for the assays and the lithology. Whatever styles that you want to display, you can do it by setting the styles for those particular fields or tables. Initially I discussed that the styles table provide the drawing styles for the drill holes that will be displayed in graphics. Okay, so I can close the database by clicking on the database in the status area and selecting close, or clicking the close to icon here, and everything will be gone. Okay, so we will do the setting of drill hole styles in the next lesson.